Okay, as usual, if you have any questions or comments, just interrupt any time. I don't mind. It's fine with me. In fact, if you don't say anything, I just feel like I'm talking to myself, and then I start to call on you involuntarily. Question? Say your name before you. Is it Lauren? What is your name? Lauren.
Blackboard is mirrored.
Blackboard is not mirrored still? Oh, that's great news. That's great news. Okay, I will send the 100th email asking them to mirror the Blackboard. If they can't mirror the Blackboard, I will duplicate and upload all the material onto the third-year module. I was hoping to avoid that, but might have to do that. Any other questions? Thank you, by the way, for pointing that out. Any other questions? What's your name? Okay, what's your name? What's your name again? Nihao?
That's too short, but Professor C wants to answer some of those information. There are questions like what is the average size of the ECCG, what are the distribution of SSG looks like, and other questions. And do we need to answer exactly that question, or we can answer any question?
Take 1 minute. I'll be back in 30 seconds while I cough. So the answer is no, you don't have to answer those questions specifically. They're just to give you a hint, like to get your mind started. Question?
Where did you?
Yeah.
I can't hear this question.
I'm sure the audience will quiet down once the excitement energy wears off and trickles down. I thought I was not going to cough, but I'm still pretty well prepared. I might have to make some pauses, to cough and stuff. It all adds to the excitement and the suspense anyways. So everybody remembers this business from last time? And we stopped when we were going to talk about color. We don't talk a lot about color. Color could be its own module, the topic of color. We're just going to briefly mention color in the context of data visualization. So for the assignments, you're expected to submit colors, visual designs with colors. Because color is really the most often used, or one of the most often used visual primitives to convey data. Now, if we're talking about categorical data, we recommend roughly a maximum of 7 different colors, plus or minus 2. Anybody here ever study art? Do you know how many different colors that we can perceive? That's a typical arts question. I don't know the answer actually, but roughly 300. So we can distinguish 300 different colors, but it's not a good idea to use 300 different colors in your assignments. Just be warned that the typical rainbow color map that you see is not linear. If you ever see a color map that's got like red, green, and blue, which is very common, you'll notice that the green occupies the most space. It's not evenly distributed between the 3 different colors. You'll also notice that color depends on the context. The color that you see depends on the surrounding colors. So here, if you're looking for effective color maps, you can go to this website called Color Brewer. I can give you a little demo right now, actually. And there it is. And it will give you some nice color map demonstrations and recommendations from a geography or a geographer's point of view. So if you're in the business of maps, which happens to be quite good for assignment 1. So we can choose different kinds of maps. I'm going to take another 60-second pause to add to the suspense. Have a look at this. It's much more interesting this way, isn't it? Much more interesting. I don't really understand coughs, but sometimes I know that like I can't speak, and then if I wait a few minutes, I can speak again. We'll see if that's still true today. So that's a nice little website and a nice tool for choosing colors. Has anybody heard of the Mach-Band Effect before? The Mach-Band Effect is an illusion. So if you look carefully at this, it looks like, for example, if we look at this rectangle, it looks like there's a gradient. It looks like this side is darker and this side is lighter. Doesn't it? That is an illusion. This rectangle and all the rectangles are actually uniform in color. There's no gradient. And the illusion is created by the rectangles on both sides. And you can prove that to yourself if you can figure out a way to cover up. This doesn't really do the job, but you can figure out. Look, it does make a difference already though, at least for me. The gradient is much less as soon as I put the papers up. Just for me, personally. I don't know if that's true for you. And that's one example of perception of color changing depending on the context. So what you perceive as yellow, for example, changes depending on the colors next to the yellow, which is kind of interesting. It also depends on what you looked at just before you looked at the yellow. So if you look at what color, anybody stare at a light and then, cover their eyes, you get the memory of what you saw in your visual system. Right? So your visual system has a memory, its own memory. And what you see currently is affected by what you looked at before. So that's a temporal context. This is a spatial context. Does everybody remember that sort of funky image that was circulated about like the dress that some people thought was yellow, some people thought it was gray? That's also a symptom or a consequence of context. The color that you saw, that you perceived when you watched that dress, was affected by the colors next to the dress and what you looked at before you saw the dress. So color is a fun topic, and it's really interesting. We won't go into it in depth. It could be its own module, and I'm not going to stand here and say I'm a color expert. It's good to know that every device has its own range of colors, and in the world of color science, that's called a color gamut, the range of colors a device can produce. So this laptop can produce one set of colors on the native display. The projector can produce a different set of colors. So these colors are not exactly the same. And when you really notice this is when you try to print something in color. Right? It's difficult to get something that's printed in color that looks like what you see on the screen. Right? It costs a lot of money to get a high quality color printout. So grayscale, some useful kind of tips. Grayscale lines look good when they're used as boundaries. Avoid dark blue for details and animations because it's difficult to see. Dark blue and red don't mix very well. As an example, I see this all the time, by the way. You can see people with PhDs that have slides with dark blue backgrounds and different colored fonts like red on it. Not a good combination. It's very difficult to see. Avoid high color frequency. That means avoid too many colors cramped in a small space. And we already mentioned the context. Context and association is important. Right? People associate certain colors with certain things. Color is good for conveying categories, also known as qualitative visualization. In other words, people cannot generally see a color and then assign a data value to that color, an exact data value, but more like a range. And we saw in the Mach-Band Effect, the color can be used to strengthen boundaries. So we see boundaries more easily when there are two different colors on either side of the boundary. Any questions about that bit? That's like the end of the introduction to data visualization. Is the attendance register being passed around? Has everybody signed it? Okay, can you pass it forward?